In this video, we're going to focus on synthesis reactions, also called combination or addition reactions. These are some of the simplest reactions to recognize. We just have multiple reactants combining to form a single product. While the pattern seems straightforward, synthesis reaction can include metals, nonmetals, ionic compounds, covalent molecules, and many other cases. So we're going to look over all of these major cases and how to balance them and predict these products. So let's start with the general form. We will always have this same pattern. A plus B yields AB. So we always result in one product. A and B can be elements or compounds or both, but that same rule that we just said still applies. It's also important to note these are often exothermic, which means that our energy gets released since there's bonds that are being formed. So some of the common types of synthesis reactions include element plus element. Now, we can break this up further by saying metal plus nonmetal. Our product here is an ionic compound. If we have nonmetals plus nonmetals, we get a covalent compound. The second type we can see are going to be compounds plus elements. Now, if we have metallic oxides, so metal with oxygens, and we react them with water, we would get what are called metal hydroxides or bases. And we can also see the opposite as when we have non-metal oxides with water being acids. Now, though this is rare, we can also have compound and compound reactions, which just give us one single larger compound. Let's look at some detailed examples now. Let's look at sodium reacting with chlorine gas. So you want to make sure that your equations are balanced. So we have 2Na plus Cl2. Again, this has to yield us one product. It's going to yield us 2 NaCl. So our reactants, we have a metal and a nonmetal, which means that our product is an ionic bond. In specific, it's an ionic salt in sodium chloride. Now, if we switch it up a little bit and react our two hydrogen gas molecules with our oxygen gas, we get H2O. So in this case, we have a nonmetal and another nonmetal, meaning our product is going to be a covalent compound, which is water. Now, these reactions can form different products under different conditions. So not in this case specifically, but if we have carbon and oxygen, we can get either CO or CO2. It just depends on what the reaction conditions are. Now let's make some of the reactants more complex. If we have calcium oxide, which is CaO, and we react it with water, in this addition reaction, we're going to get our calcium hydroxide. Now, if you remember at the beginning, this is a base, calcium hydroxide. So we have a metal oxide, which again is just a metal and oxygen. And when we add it to water, we get our metal hydroxide, which we already said are our bases. So now looking at the other example that we saw at the beginning, if we have something like sulfur trioxide, SO3, plus water again, we're going to get our acid. We're going to get our H2SO4. So let's break this down. We have a nonmetal with our oxide again. We have a nonmetal with oxygen attached to it. And then we have water. So our nonmetal oxide plus our water gives us an acid. In this case, we get sulfuric acid. Now, to bring up a point I made a couple minutes ago, where there are multiple possible products depending on our conditions. So if we have carbon and we mix it with oxygen, we would get carbon dioxide, CO2. Here, we have our excess oxygen. But if we look at a case where we have more carbon than oxygen, we have a limited amount of oxygen this time in 2C plus O2. So we just added a coefficient of 2 in front of our carbon. Now from this, we get 2 carbon monoxides. So when we have our excess oxygen, we get CO2. We get more oxygen in our product. When we have limited oxygen, we get CO, carbon monoxide, which has less oxygen. So looking at another video, another topic, this is why some incomplete combustion produces carbon monoxide instead of carbon dioxide, because of this idea here, that the product forms depends on the oxygen availability. Some key characteristics to remember about synthesis reactions is first, that there's only one product. This is always the case. Now, we didn't explicitly mention this, but you want to watch for your diatomic elements. Now, this is just a list of elements that you can remember, where essentially when they're standalone in a reaction, there's 2 of them and they form a molecule rather than just the individual element. It's also important to look at oxidation states. Also, our hydration reactions, they give us acids and bases. Again, that would be a very helpful rule to know when we have an oxide, so something that has oxygen, the metal will give us the base, the nonmetal gives us the acid. Again, these are when we're reacting with water. Lastly, what we just saw in our last example, that conditions change products. So things like temperature or oxygen availability, like we saw, they can force changes that give us different products. Let's talk about a step-by-step strategy that you can apply to your chemistry courses. So the first step is to identify your reactants. So this is to see, are they elements, are they oxides, are they compounds, what type of reactants are we working with? Next, you want to predict the product. Again, since we're talking about synthesis reactions, they're going to combine into a single compound. Now, this is important that you want to make sure your equation is completely balanced. All your subscripts and coefficients actually are correct in order to predict the correct product. Then, you want to write the complete equation. Again, this kind of piggybacks off of the second point. You want to make sure all your coefficients and charges are all correct in order to write the complete correct equation. After this, you would essentially balance it and then check what type of products you have. Now let's do a couple more practice problems to look at what we learned. So the first one is combining magnesium and oxygen. Again, we know we're doing synthesis, we're going to get one product. We need to make sure this reaction is balanced first. So looking at the charges, I know I'm going to need 2 magnesium for these 2 oxygen. My product is going to be 2 MgO. This checks out because our equation is balanced. All of our charges end up working out, and we only have one product. So here we get magnesium oxide as our answer. For number 2, aluminum and sulfur. Now, we have to look for their charges and make sure that they're all balanced. So we have 2 aluminum, and 3 sulfur. This yields aluminum sulfide, which will be Al2, S3. Next, we have carbon dioxide and water, CO2 and H2O. Here, we get carbonic acid, which is H2CO3. Now the last one I wrote out in words, iron plus oxygen. The reason why is because there's multiple oxides, multiple oxidation states that we could have here. We can have iron 3 or iron 2. Iron 3 is the most common. It's just iron rusting. So the Roman numerals that are referring to iron is going to be its oxidation state, it's going to be its charge. So if we were to rewrite it with the iron 3 having a charge of our +3, we would have Fe plus our O2, our diatomic element. We would need 4 of our irons and 3 oxygens, giving us a product of 2 Fe2O3. Now if we had iron 2 instead, which is less common, but it's still possible, now our coefficients would change, and so would our product. We'll have 2 iron plus our diatomic element again, giving us 2 iron oxide. If you found this video helpful, check out the full overview video where we cover 5 reaction types together, which will be linked in the description below. Don't forget to like and subscribe if this helped you. Thanks for watching.